The Bayes notation used with ERDs, with original Chern notation and the newer Crawford and UML notation. The Chern notation favors conceptual modeling. The Crawford notation favors a more implementation-oriented approach. The UML notation can be used for both conceptual and implementation modeling. The relational database model that the ERM forms the basis of an ERD. The ERD represents the conceptual database as built by the end user. ERDs depict the database main components, entities, attribute relationships. Because an entity represents a real-world object, the words entity and objects are used interchangeably. The order in which the ERD components are covered is dictated by the way the modeling tools are used to develop ERDs that can form the basis for successful database design and implementation. Recall that an entity is an object of interest to the end user. An entity actually refers to the entity set and not to a single entity occurrence. In other words, the word entity corresponds to a table, not to a row in the relational environment. It refers to a table row. The ERM refers to a table row as an entity instance or entity occurrence. In both the Chern and Crawford notation, an entity is represented by a rectangle containing the entity name. The entity name is usually written in all capital letters. Attributes are characteristic of entities. The student entity includes, among many others, the attribute name initial. In the original Chern model, attributes are represented by overs and are connected to the entity rectangle with a line. In the Crawford notation, the attributes are written in the attribute bars below the entity rectangle. Because the Chern representation is rather space-consuming, software vendors have adopted the Crawford's attribute display. A required attribute is an attribute that must have a value. In other words, it cannot be left empty. There are two boldface attributes in the Crawford's notation. This indicates that a data entry will be required. There are two boldface attributes in the Crawford's notation. This indicates that a data entry will be required. In this example, name require data entries because of the assumption that our students have a last name and a first name. But students might not have middle name and perhaps they do not have phone number and email. Therefore, those attributes are not presented in boldface in the entire entity bars. An optional attribute is an attribute that does not require a value, therefore it can be left empty. Attributes have a domain. A domain is a set of possible values for a given attribute. For example, the domain for the grade point average is returned 0, 4 because lowest possible is 0 and highest 4. The domain for the gender attribute consists of only two possibilities, M or F. The domain for a company date of higher attribute consists of dates that fit in range. For example, companies that update to current day. Attributes may share a domain. For instance, student address and professors share same domain of all possible address. The data dictionary may lack a newly declared attribute, inherit the characteristic of an existing attribute if the same attribute name is used. For example, the professor and student entities may each have an attribute name, address, and could therefore share a domain. The professor and student entities may each have an attribute name, address, and could therefore share a domain. Professor and student entities may each have an attribute name, address, and could therefore share a domain. The ERM uses identifiers that is one or more attributes that uniquely identify each entity instance. In the relational model, such identifiers are mapped to primary keys in tables. Identifiers are underlined in the ERD. Key attributes are also underlined in the frequently used table structure shorthand. Key attributes. Ideally, an entity identifier is composed of only a single attribute. For example, a class table uses a single attribute primary key named classical. However, it's possible to use a composite identifier that is a primary key composed of more than one attribute. The Tiny College database administrator decided to identify each class entity instance by using composite primary key composed of combination of code and class sessions instead of using classical. Either approach identifies each entity instance given the current structure of the class table. The code is the primary key and the combination of the current session is a proper candidate key. If the classical attribute is deleted from the class entity, the candidate key becomes an acceptable composite primary key. Proper candidate key. If the class code is used as the primary key, the class entity may be represented in shorthand form by the first one as class code. On the other hand, if class code is deleted and the composite primary key is the combination of serious code and class section, the class entity may be represented by class and then bracket CRS code class section. A single value, note that both key attributes are underlined in the entity notation. A single value attribute is an attribute that can have only a single value. For example, a person can have only one social security number and the manufacturer part can have only one serial number. Keep in mind that a single value attribute is not necessarily a simple attribute. A serial number is single value but it's composite attribute because it can be subdivided into the region in which the part was produced. A prime within the region is shift within the prime and the part number. Multi-value attributes are attributes that can have many values. For instance, a person may have several college degrees and a household may have several different phones. Similarly, a color may be subdivided into many colors. In the Tron ERM, the multi-value attributes are shown by a double line connecting the attribute to the entity. The crossword notation does not identify multi-value attributes. Note that it is the primary key and color is the multi-value attribute of the car entity. Car is the primary key, while color is the multi-value attribute of the car entity. Attributes are classified as simple or composite. Composite attribute, not to be confused with a composite key, is an attribute that can be further subdivided to your additional attribute. For example, the attribute address can be subdivided into string, city, state, and zip code. And similarly, the attribute for number can be subdivided into area code and exchange number. A simple attribute is an attribute that cannot be subdivided, like age, sex, marital status will be classified as simple attributes. To facilitate detailed queries, it's wise to change composite attributes into a series of simple attributes. Attributes that cannot be subdivided, like age and marital status. Although the conceptual model can handle many-to-many relationship and multi-value attributes, you should not implement them in the RDBMS. Remember that in the relational table, each row intersection represents a single data value. So if multi-value attributes exist, the designer must decide on one of two possible courses of action within the original entity, create several new attributes, one for each of the original multi-value attribute components, like car entity attribute. Color can be split to top color, body color, trim color, which are then assigned to car entity. In the ERD model, the car entity foreign key has been typed as code. This attribute was manually added to the entity. Actually, proper use of database modeling software will automatically produce the foreign key when the relationship is defined. In addition, the software will label the foreign key appropriately and write the foreign key implementation details in a data dictionary. Therefore, when you use database modeling software, like be sure never type the foreign key attribute yourself and let it handle the task when the relationship between the entities is defined. Although this solution seems to work, its adoption can lead to major structural problems in the table. For example, if additional color components like logo color are added for some cars, the table structure must be modified to accommodate the new color section. In that case, cars that do not have such color section generate null for the non-existing components, or the color entries for those sections that enters NA to indicate not applicable. Imagine the solution splitting a multi-value attribute into new attributes will cause problems if it will apply to an employee entity containing employee degrees and certification. If some employees have 10 degrees and certification, while most have fewer or not the number of degree certification attributes will number 10, and most of those attribute values will be null for most of the employees. In short, your thing is not an acceptable solution. A new entity set composed of multi-value attribute components. Secondly, another solution is create a new entity composed of the original multi-value attribute component. This new entity allows the designer to define color for different sections of the car. Then this new color entity is related to the original color entity in a one-to-many relationship. Creating a new entity in a one-to-many relationship with the original entity yields several benefits. It's more flexible as bendable solution, and it is compatible with the relational model. Finally, an attribute may be classified as a derived attribute. A derived attribute is an attribute whose value is calculated from other attributes. The derived attribute need not be physically stored within their database. Instead, it can be derived by using an algorithm. For example, an employee age may be found by computing the integer value of the difference between the current date and an employee's age may be found by computing the integer value of the difference between the current date and point. If you use Microsoft Word SAS, you will use the formula int date emp divided by derived attribute derived by using an algorithm. In Microsoft SQL, you use select date difference. The first parameter indicates where date difference is a function that computes the difference between the date. The first parameter indicates the measurement. If you use Oracle, you will use SY as DAT instead of date. You're assuming, of course, that the employee will start in the Julian date format. Similarly, the total cost of an order can be derived by multiplying the quantity ordered by the unit price. Order estimated average speed can be derived by dividing trip distance by the time spent on road. Total cost of an order can be derived. Total cost of an order can be derived by multiplying the quantity ordered by the unit price. A derived attribute is indicated in the trend notation by a dashed line connecting the attribute and the entity. The Crawford notation does not have a method of distinguishing the derived attribute from other attributes. The Crawford notation does not have a method for distinguishing the derived attribute from other attributes. Derived attributes are sometimes referred to as computer attributes. A derived attribute computation can be as simple as adding two attribute values located on the same row, or it can be the result of aggregating the sum of values located on a derived attribute. A derived attribute computation can be as simple as adding two attribute values located on the same row. A derived attribute computation. A derived attribute computation can be as simple as adding two attribute values located on the same row, or it can be the result of aggregating the sum of values located on many table rows. A derived attribute computation can be as simple as adding two attribute values located on the same row, or it can be the result of aggregating the sum of values located on many. It can be the result of aggregating the sum of value located on many table rows from the same table or from a different table. The decision to store derived attributes in database tables depends on the processing requirements and the constraint placed on a particular application. The designer should be able to balance the design in accordance with such constraints. Derived attribute store advantage. Save CPU processing cycles. Derived attribute store advantages save CPU processing cycles. Store derived attribute save CPU processing cycles, save data access time, data value is readily available, can be used to keep track of historical data. Disadvantage is requires constant maintenance to ensure derived value is current, especially if any value used in the calculation change. North Star advantage is safe storage space and computation over your current value. North Star means safe storage space computation over your current value. Disadvantage is use of CPU processing cycles, increase data access time, adds coding complexities to query. Star is disadvantages requires constant maintenance to ensure derived value is current, especially if any values used in the calculation change. Requires constant maintenance to ensure derived value is current, especially if any values used in the calculation change. Relationships. Records that a relationship is an association between entities. The entities that participate in the relationship are also known as participants, and each relationship is identified by a name that describes the relationship. The relationship name is an active or passive verb. For example, a student takes a class, a professor teaches a class. The relationship classification is difficult to establish if you know only one set of relationship. If you specify that a division is managed by one employee, you don't know if the relationship is one-to-one or one-to-many. Therefore, you should ask the question, can an employee manage more than one division? If it's yes, the relationship is one-to-many. The second part of the relationship is that return as an employee may manage many divisions. If an employee cannot manage more than one decision, that is 1-to-1, and that an employee may manage only one division. Relationship between entities always operate in both directions. That is, to define the relationship between the entities named customer and invoice, you will specify that a customer may generate many invoices, or each invoice is generated by one customer. Because you know both directions of the relationship between customer and invoice, it's easy to see that this relationship can be classified as one-to-many. Entity relationship may be classified as one-to-one, one-to-many, and many-to-many. Relationship were depicted in the Chern and Crawford notation, where the term connectivity is used to describe the relationship classification. Cardinality expresses the minimum and maximum number of entity occurrences associated with one occurrence of the related entity. In the ER, as the minimum and maximum number of the entity occurrence express the minimum and maximum number of entity occurrence associated with one occurrence of minimum and maximum number of entity occurrences associated with one occurrence of the related entity. In the ER, the cardinality is indicated by placing the appropriate numbers beside the entity using the formula as y. The first value represents the minimum number of associated entities, while the Second value represents the maximum number of associated entities. Many database designers who use Crawford's modeling notation do not depict the specific cardinality on the ER diagram itself, because the specific limits described by the cardinalities cannot be implemented directly through the database design. Correspondingly, some Crawford ER modeling tools do not print the numeric cardinality range in the diagram. Instead, you can add it as text if you want to have it shown. When the specific cardinalities are not included on the diagram in Crawford notation, cardinalities implied by the use of the symbols which describe the connectivity and participation. The numeric cardinality range has been added using the visual text drawing tool. Knowing the minimum and maximum number of entity occurrences is very useful for application software level. For example, tiny college might want to ensure that a class is not taught unless it has at least 10 students enrolled. Tiny college might want to ensure that a class is not taught unless it has at least 10 students enrolled. Similarly, if the classroom can hold only 30 students, the application software should use the cardinality to limit enrollment in the class. However, keep in mind that the DBMS cannot handle the implementation of the cardinalities at the table level. That capability is provided by the application software or by trigger. As you examine the Crawford diagram, keep in mind that cardinalities represent the number of occurrences in the related entity. For example, the cardinality 1 for return next to the class entity in the professor-teacher's class relation. Cardinality represents the number of occurrences in the related entity. The cardinality return next to the class entity in the professor-teacher's class relationship indicates that each professor teaches up to 4 classes, which means the professor table primary key value occurs at least once and no more than 4 times as foreign key values in the class table. If the cardinality returns 1n, there will be no upper limit to the number of classes as professor might teach. Similarly, the cardinality 1 return next to professor entity indicates that each class is taught by one and only one professor. Each class entity occurrence is associated with one and only one entity occurrence in each class entity occurrence is associated with one and only one entity occurrence in professor. Each class entity occurrence is associated Each class entity occurrence is associated with one and only one entity occurrence in professor. Connectivities and cardinalities are established by very concise statements known as business rules. Such rules derive from a precise and detailed description of an organizational data environment. Also establish the ERM's entity attribute relationship, connectivities, cardinality, and constraint. Because business rules define the ERM's component, making sure that all appropriate business rules are identified is a very important part of our database designer job. An entity is said to be accidents dependent if it exists in a database only when it is associated with another related entity occurrence. In implementation terms, an entity is accidents dependent if it has a mandatory foreign key. There is a foreign key attribute that cannot be null. For example, if an employee wants to claim one or more dependents for tax withholding purpose, the relationship employee claims dependent will be appropriate. In that case, the dependent entity is clearly assistance dependent on the employee key because employee entity because it is impossible for the dependent to access apart from the employee in the database. It is impossible for the dependent to access apart from the employee in the database. The prevalence of cardinalities in ER diagram is a matter of convention. The Chow notation places the cardinality on the side of the related entity. The Crawford's and URL diagrams place the cardinalities next to the entity to which the cardinalities apply. The Crawford and URL diagrams place the cardinality next to the entity to which the Crawford and URL diagram place the cardinalities next to the entity to which the cardinality apply.